Question number 3, part A deals with if there is a current flowing in a wire I, N is number of electrons per unit volume, A is cross-sectional area, E is the charge on electron, and Vd is drift speed, then the current flowing in the wire is nAeVd. Suppose you have a wire of cross-sectional area A and charge is flowing. You can think of as some fluid is flowing in this pipe. Water flows in a pipe. Similarly, electrons flow in a wire. If it is moving with a certain speed, after some time, part of this will come out. This part, if area is A, this area is A. Drift speed is Vd, then distance covered in 1 second is Vd into 1. So what is the volume of this part? Volume of this part is A into Vd. If there are a certain number of electrons, say like dust particles in water, similarly you have electrons. If N is number of electrons per unit volume, then suppose 100 electrons per liter and this volume is a 10 liter. 100 electrons per liter and volume is 10 liter. How many electrons are there? 1000. So, number of electrons coming out per second is equal to what? nAeVd. N represents what? N represents number of electrons per unit volume and A into Vd represents volume coming out per second. 2 minutes with you to draw the diagram and write. 2 minutes. Area of the wire is A. Just like water flows in a pipe, electrons flow in a wire. In this arrangement, if Vd is the speed, then distance covered, this whole thing comes out. In 1 second, what is the distance covered? Vd is the distance covered per second into 1. So Vd into 1, this is the distance covered. What is the volume of this cylinder? This cylinder, area into length. Length is Vd into 1. Number of electrons per unit volume is N. Small n represents what? Number of electrons per unit volume. A into Vd represents what? Volume coming out per second. So nAeVd represents what? Number of electrons coming out per second. I or current is what? Charge flowing per second. charge on one electron is E, then it can be written as electrons coming per second, number of electrons coming per second. This part you have already answered, number of electrons coming out per second. These are all red color means electrons. How many? nAeVd. It is nAeVd. I is equal to what? nAe. 2 minutes with you to complete. B part is Ohm's law. Ohm's law. Two forms of the same. One is J is equal to conductivity times E and V is equal to I into R. This is the macroscopic form which you have applied in school. J into conductivity times E is also the same. These two expressions you will find are identical. The law is, if there is a wire of resistance R, resistance of the wire is R. If you connect a voltage battery across the same V, then the current flowing in the wire I, relationship between V, I and R is what? V is equal to I into R, Ohm's law. I is equal to nAeVd. You have already proved in the previous part, this one, A part. nAe. What is the value of Vd? You have covered yesterday. Mobility times E. Correct? What was mobility equal to? E tau by m. Now it is n a E square tau by m into E. I is current flowing. A is cross-sectional area. Current flowing per unit area, I by A, is termed as current density J. So I by A is what? I by A is equal to n E square tau by m into E. Current flowing per unit area is current density J. This parameter n E square tau by m depends on metal. It varies from one metal to other metal. It is termed as conductivity, is property of the material. This is conductivity. J is what? Current density. J is equal to conductivity times E is microscopic form of Ohm's law. Time with you is 3 minutes. J is equal to conductivity times E. We want to change it to V is equal to I into R form. What is J? J is current per unit area. We want to change this form. J is equal to conductivity times E2, V is equal to I into R. So that is why I am changing J to I. So current flowing per unit area is I. If L is the length, electric field is change in voltage by change in length. E is equal to what? Total voltage divided by total distance. Voltage gradient. It is equal to conductivity V by L. You want a relationship between V and I. I is equal to conductivity, area, length, V. Or you can write like this also. V is equal to something I. This is equal to what? L by conductivity A. And in school, you have written this like conductivity of a material. Relationship between conductivity and resistivity is what? This is conductivity and this is a resistivity. Resistivity is a reciprocal of a conductivity. So if you want to write it like this, you can write like this also. Resistance of the wire R is equal to what? Rho L by A. Resistivity is a property for a copper wire, whatever be its length, size, area. Resistivity is a property of material, copper. Resistivity of copper, one value. But if you make a wire of one length, 1 meter, resistance is different. If you make a wire of length 2 meters, then resistance is different. Resistance depends on property of the material, length, area, that means physical dimensions also. A thin wire, less area, will have more resistance. A thick wire will have more area, less resistance. So resistance depends on property as well as physical dimensions of the material, wire, object. So this whole thing is written as resistance. V is equal to R into I. This is Ohm's law in macroscopic form. Macro form of Ohm's law. 2 minutes with you. 2 minutes to write. Refer to numericals. Numerical number 6. Numerical number 6 is a uniform wire of length 1 meter and cross-sectional area 5 into 10 power minus 7 meter square carries a current of 1 ampere. Assuming that there are 8 into 10 power 28 free electrons per cubic meter in copper, how long will an electron take to drift from one end of the wire to the other? Draw the diagram, write what is given. There is a wire of length L. How much? 1 meter. Cross-sectional area A given. There is a current flowing in the wire I given. What is the current flowing? Yes, 1 ampere. What is the length? 1 meter. Area? Yes, minus meter square. What else? Number of electrons per unit volume? N. 8 into 10 power 28. So many electrons per meter cube. Anything else? Charge on the electron is also given. 1.6 into 10 raised to power minus 19 coulomb given. This is something given. You have to find out what. How much time it will take for electron to drift from one end to the other. That means in step 1, you need to find out speed. If you can find out the drift speed of the electron, time taken is what? Distance by speed. Distance is L divided by V, so distance by speed. Formula to be used. I is equal to nAeVd. I is equal to what? 1 ampere. N is equal to what? 8 into 10 raised to power 28. Area 5 into 10 raised to power minus 7. Charge on electron 1.6 into 10 raised to power minus 19. Vd we don't know. So solve it to find the value of Vd. Vd comes out to be what? Yes, anyone? Yes? 1 by 64? 6400. Check it please. Vd is 6400? 1 by 6400 meter per second. This is 1. Step 2. Yes. What we want to find out is time. How much time it will take. Time taken is equal to distance covered divided by speed. Distance covered is how much? Electron drifts from one end to the other end. I have drawn it a straight line for convenience, but it follows a zigzag path. Its drift speed means effective speed. Distance is how much? 1. Vd is equal to what? 1 by 6400. What to get is 6400 seconds. 6.4 and 10 power 3 seconds. So time comes out to be 6.4 into 10 power 3 seconds. Try numerical number 8. Numerical number 8. Numerical number 8 is a uniform wire of length L and radius R has a resistance 100 ohm. It is recast into thin wire. Part 1, length 2L. Part 2, that is second, radius half. Calculate the resistance of new wire in each case. So, experiment number 1, length is how many times? 2 times. So, draw the diagram. It is diagram based question. If you don't draw the diagram, you won't get the answer. Draw the diagram. What is the resistance of the wire? 100 ohm. So there is a wire. Part 1 we can handle on this side. There is a wire of resistance. Length is L. Cross sectional area is A. You recast means what? You first melt it and make a new wire. Of what length? 2 times. So draw the new wire. New wire should have what length? 2 times. What about area? Half. Why? Volume of the material remains the same. You have one wire of length L, area A, melt it. The volume remains same. So, when you make it double the length, then area, new length L dash is 2 times new area, yes, new area A dash is half of original. Product of area into length remains the same. So, what was the resistance of the wire R? Is equal to rho L by A. New resistance R dash is equal to rho L dash by A dash. From these two equations, what you want to find out is new resistance R dash is how many times R? New resistance R dash is how many times R? Yes, R dash by R is equal to what? L dash by L, A by A dash. Directly proportional to length, inversely proportional to area. L dash by L. L dash is how many times L? 2 times. A dash is A by 2 or A by A dash. A divided by A dash is how many times? 2. What to get is 4. This new wire will have resistance 4 times original. R dash is 4 times R. What was R equal to? 100. R is 100. 4 into 100 comes out to what? 400. So R dash is 400 ohm. Competition. This formula only, R is equal to rho L by A. L is how many times? Area is half. It is 2 times, this is half. You take it to the numerator, 4. So new resistance is 4 times. Objective question. Total time available less than 1 minute. Try second part, B part of the same question. B part is half of the radius. This is part 1 of the question. Part 2 of the question is, there is a wire and new wire is, yes, new wire is having what radius? Original wire is having radius R, new radius R dash is R by 2. Try. Time with you is 2 minutes. Think of area and length. What is area for the first one? Pi r square. What is area for the second case? Pi r dash square. R dash is, yes, half square is equal to what? Pi r square by 4. New area A dash is 1 by 4. Yes. Length. If original length is L, what is new length equal to? Yes. Area is 1 by 4. This area A dash is 1 by 4 of original area. The length comes out to be how many times? 4 times. So this is part 1. R is proportional to L by A. L is how many times? 4 times. Area is how many times? 1 by 4. So resistance, new resistance is how many times? 16 times. So 16 into 100 is 1600